Well, hi, everyone. My name is Josh Isaac. I'm head of quantum software here at Xanadu, and today I'll be talking about our PennyLane software stack. So what is PennyLane? PennyLane is an open source framework for programming quantum computers. We created PennyLane back in 2017 because we noticed there was something missing from quantum computing. There was no quantum framework that integrated seamlessly with the existing scientific ecosystem while providing flexibility and intuitivity. Researchers didn't want to use monolithic, already crafted algorithms, but they wanted to explore and prototype and create their own. More so, existing research and exploration relies daily on mature tools such as machine learning frameworks like PyTorch and TensorFlow. And we want to make it possible to keep using those established tools, but introduce quantum computing and quantum hardware into those workflows. Especially because with near-term devices, algorithm development is not purely quantum, but includes aspects of quantum and classical. So PennyLane takes this into account. It allows you to make your existing workflows and models quantum aware. In essence, training a quantum computer the same way you would train a neural network. So since 2017, PennyLane has grown a lot, with a focus beyond just machine learning to applications, optimization, and education. Everything we do is open and in the public, and we have developed a huge focus on our community as well. With such a nascent field, we want to hear how people are using PennyLane and learn what we can do to help make PennyLane a tool that drives forward research and exploration. So we're not just a quantum programming framework, but we're also a community and an educational resource. Another thing that we really wanted to do with PennyLane was that while we are in this near-term era of quantum hardware, not all quantum hardware is the same. We have quantum hardware from different vendors, and we have quantum hardware across different architectures, from photonics to trapped ions to superconducting qubits. And we are still in a stage where certain architectures might be better suited for different applications. There's no one particular architecture or device that we want to lock ourselves into, but we want the ability to play around with all of them. Not only that, but we want to include multiple hardware architectures in the same application or the same model. Something like the ability to train a trapped ion device and a superconducting qubit device simultaneously. So we've taken a very much a hardware agnostic approach with PennyLane. We want to support as many different architectures as possible. And at the moment we support 7, which is a leader in the field. And we also want to ensure that you can mix and match, change them easily, and use multiple at the same time. So something else we acknowledge is that quantum computing is difficult. It's a hard field, which is why we have also built up alongside PennyLane this community so that we can sort of ride this wave together and help each other out. So these stats just show where we are today with this community. So what we've been doing is establishing engagement across different areas. So across software, social media, direct company engagement, and also events. So something I want to emphasize is that PennyLane is bigger than just us here at Xanadu. So we have our annual developer conference, QHAT conference, which is an event for engaging with us and fostering the quantum programming ecosystem as a whole. So we want to bring in companies across the spectrum, non-profit organizations, universities, to celebrate the whole quantum programming ecosystem. At the same time, we've been working hard and exploring partnerships with PennyLane and signing up startups who are interested in the PennyLane platform to build on PennyLane to provide additional services and products. So these include startups like Menton AI and Agnostic. At the same time, we've been working with other companies who have been backing our vision with PennyLane, such as AWS. Something I can share with today is we've just announced new work with BMW on tensor networks, a new approach to building quantum circuits. Part of our open ethos and our drive on a community, not just a programming framework, is we realize that because quantum computing is hard, we want to share the lessons we have learned and the things you can do with quantum computing and quantum programming. So we don't just want PennyLane to be that flexible tool to do what you need it to do in research and development, but we also want to provide the resources to go from beginner to expert just from using PennyLane. So on our website, we have a large range of quantum computing demonstrations and tutorials accessible for free. I think as of this morning with the BMW Tensor Network demonstration we uploaded, we have 80 demos. And these range from learning the basics of quantum programming to applications and optimization and quantum chemistry, as well as learning the theory and fundamentals of quantum computing. So you can best place where quantum computing will fit into what you're building and what your needs are. So yeah, we'd love to get in touch with you to find out how PennyLane can help build what you're looking to build. Thank you.